S3.6 Scatter graphs. In lesson S1.1, we looked at the data handling cycle. In chapter 2, we started looking at the parts of the data handling cycle where we process and represent data, then interpret data. We did this using averages. In chapter 3, we are continuing to look at processing and representing data and interpreting data, but this time in a very visual way, by using a variety of charts and graphs. We are learning both how to draw the different statistical diagrams and also use them to interpret and analyze sets of data. In today's lesson, we will look at scatter graphs. Scatter graphs, or scatter diagrams, are used to display two sets of data, or bivariate data, to see if there is a relationship or correlation between them. As well as being able to plot and analyze scatter graphs, there is a lot more information you need to know. We will use the following question to work through these. Let's have a look at the question. The scatter graph below shows the time spent revising and the test results of some students. So in this question, there are two sets of data. The time spent revising in hours and the test result as a percentage. On the scatter graph, the x-axis represents one of the variables, in this case, time spent revising. The y-axis represents the other variable, in this case, the test result. Both bits of information were recorded for a group of students. For each student, a point is plotted. For example, this student here spent no time revising, however got a test result of 18%. It's important that you are confident with the scales of both the x and y axis. And this student here spent 3.5 hours revising and got a test result of 70%. And so on. It then says that the table below shows the information for another 3 students. Plot this information on the scatter graph. So this is part A. We need to plot the information that's given in this table on the scatter graph. So looking at the table, the top row tells us the time spent revising in hours, and the second row tells us the test result in percentage. So this first student here spent 6 hours revising and got a test result of 90%. So we need to plot this point on the scatter graph first. We need to go along the x-axis until we reach 6 hours revising, and then up the y-axis until we reach a score of 90%, and then we plot our point with a cross, like so. Notice how I'm plotting my point with a cross rather than a dot to make sure it is visible but also accurate. So the next student spent 2.5 or 2.5 hours revising and got a test result of 40%. So we go along the x-axis until we reach 2.5 hours, and then up the y-axis until we reach 40%, and plot that student's point there. The last student in the table spent 3 hours revising and got a test result of 52%. So we go along the x-axis to 3 hours and up the y-axis to 52, which is just here, and that's the point plotted for that student there. So there is our completed scatter graph showing the time spent revising in hours and the test results in the percentage for a group of students. So let's start analysing the scatter graph by answering the questions. Part B. How many students are shown in the scatter graph? Well, we know that each individual student is represented by a cross. So to answer this question, we simply need to count how many crosses there are. So I don't lose count, I'm going to cross them off as I go. So I'm starting from the left-hand side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the scatter graph shows the results for 16 students. Part C. What score did the student who spent 2 hours revising get? So for this question, we need to find 2 hours revising on the x-axis. We need to read up until we hit the point, like so, and then we can read across to the y-axis to find their test result. So that student there got a test result of 46%. So the student who revised for 2 hours achieved 46% on their test. Part D. How long did the student who got a score of 65% spend revising? So this time we are working the other way on the graph. We need to find a test result of 65% on the y-axis. We then need to read across to the point and then read down to find out how much time they spent revising. So that student spent 4.5 hours revising. So the student who got a score of 65% spent 4.5 hours revising. Part E. What was the longest amount of time a student spent revising? So for this question, we need to look for the point or points that are the furthest to the right or the furthest along the x-axis. And in fact, it's these 2 points here. Both of those students spent 6 hours revising, which was longer than any of the other students. Part F. What was the lowest score a student received in the test? So for the lowest score, we need to find the point or points that are furthest down, which is this point here, and they had a test result of 10%. So the lowest score a student received was 10%, lower than any of the other students. Part G. How many students spent less than 2 hours revising? So we need to be careful with the wording here. Less than 2 hours revising means that that doesn't include people who spent exactly 2 hours revising. So for this question, if we find out where 2 hours is on our scatter graph, and we find all the points that are to the left of that. So we've got 1, 2, 3, 4. The point on the line isn't included, so there were 4 students that spent less than 2 hours revising. Part H. How many students scored at least 70% in their test? So again, be careful of the wording. At least 70% means that 70% is included, so it's 70% or more. So we're looking for a test result of 70%, and anything there or above. So that's 1, 2, 3, 4, 5, and also this person here on the line. So 6 students received a score of at least 70%. So it's your turn now to have a go at some questions. You'll be plotting a scatter graph and also answering some questions about the information within it. Pause the video to copy the notes, to check your understanding and to try the questions from I'm giving it a try. Remember to mark your work and reflect on your confidence. Unpause the video when you are ready to try the next question. Question I. Describe the relationship shown in the scatter graph. And question J. Describe the correlation. So questions I and J come hand in hand. This is where we are going to look at the trend or pattern formed by the points. So for question I, we need to describe the relationship shown in the scatter graph. This is asking you to describe the connection between the data in a real-life context. In our scatter graph, as we go further along the x-axis, the points are plotted further up the y-axis. In other words, generally, the more time spent revising, the higher the test result. For question J, we need to describe the correlation. So here, we need to say whether the data has a positive correlation, a negative correlation, or no correlation. A positive correlation means that as one variable increases, so does the other. The points are going uphill. A negative correlation means that as one variable increases, the other decreases. The points are going downhill. And no correlation means that there is no connection between the two variables. The points are all over the place. In our question here, the points are generally going uphill. Therefore, the scatter graph has a positive correlation. There is a positive correlation between the time spent revising and the test result, because as one of the variables increases, so does the other. Part K. Draw a line of best fit. A line of best fit is a straight line that goes as centrally through the points as possible. It does not have to go through any of the actual points, and you should also try not to force your line to do this. It is very tempting to try and make your line of best fit go through the origin, but again, unless your data actually suggests that, you should try not to force your line of best fit to do that. Lines of best fit can also vary slightly, so my line of best fit may be slightly different to your line of best fit. Overall, it should be a sensible representation of the trend and steepness of the plotted points. So something a bit like that. Notice I haven't forced my line to go through the origin. And although my line does go through two of the points, that just happened naturally. I didn't force it to do that. Notice as well how there is a point that doesn't fit in with the rest of the data over here. We will look at this shortly, but I'm not letting that point be taken into account when drawing my line of best fit. As that point doesn't fit in with the rest of the data, I don't want it to cause bias in my line of best fit. Part L. Another student takes the test. Use your line of best fit to estimate their score if they spent 1.5 hours revising. So for this question, we need to go along to 1.5 hours. And we need to draw a line up until we hit the line of best fit. We then need to read across to find out their test result, which is pretty close to 30%. So if another student takes the test and they spent 1.5 hours revising, I can use my line of best fit to estimate that their score would be 30%. Your answer may vary slightly to mine, depending on the position of your line of best fit. Make sure you show your working out lines on your graph so the examiners can see that your answer has come from a correct method. So these blue lines that I've drawn on my scatter graph, I'm going to leave them in there to show the examiner my method for that question. Part M. Use your scatter graph to estimate the time spent revising for a student who scored 90%. So we're going to do a similar method, but this time from the y-axis, from the test result. So we find 90% and read across until we hit the line of best fit. So even though there is a point that has been plotted for a student who did score 90%, I'm using the line of best fit rather than that point. That's because the line of best fit takes into account the general trend of all of the data rather than just one point. Then I'm going to read down and find out how long they would have spent revising. So this is quite a tricky scale along the x-axis. So each full hour is broken into 5 smaller squares. So 1 hour is 60 minutes. If we divide that by 5, that tells us that each of the smaller squares represents 12 minutes. So it's one small square less than the 6 hours. So it's approximately 5 hours 48 minutes. So because you are working with your line of best fit, you may end up having to work out some quite awkward numbers using your scale. Again, your answer may vary slightly from mine because your line of best fit may be in a slightly different position to mine. And again, make sure you keep your working out lines on your graph. So I'm going to keep these orange lines in there to show the examiner my method. So using my scatter graph, for a student who scored 90%, I would estimate that they spent around about 5 hours 48 minutes revising. So although part L and part M are still estimates, they are quite reliable estimates. This is because we are using the line of best fit, and this takes into account the general trend of all of the data, or all of them except any outliers, which we'll talk about in a moment, rather than looking just at individual points of data. Questions L and M are examples of interpolation. Interpolation is where you estimate values that lie within the range of data. Part N. Explain why it might not be appropriate to use your line of best fit to estimate the test result for a student who spent 10 hours revising? Well, if we look at our set of data, you can see that 10 hours of revision is outside of the range of our data. Remember, the longest amount of time any of the students recorded spent revising was 6 hours. We could continue our line of best fit further, but we would be making an assumption that the data continues in the same trend. As well as that, if we did continue our line of best fit, it would take us to more than 100%, which would be impossible as well. Making assumptions about data that is beyond the range of data that you have is very unreliable. This is an example of extrapolation. Extrapolation is where you estimate values that lie outside of the range of data. It is unreliable. So, to explain why it might not be appropriate to use your line of best fit to estimate the test result for a student who spent 10 hours revising, I would write the following. 10 hours revising is beyond the range of the data. This is extrapolation, therefore may not be reliable. Part O. Circle the outlier. What does this outlier represent? So an outlier, or an anomaly, is a piece of data which does not fit with the rest of the data. In this example, the outlier is here. It represents a student who only spent 1 hour revising, but who got a very high test result of 95%. This is likely to be a student who already had a good understanding of the work that needed revising, or something similar to that. So that student's data doesn't quite fit in with the rest of the data. So that completes our analysis of the scatter graph. It's your turn to have a go at doing the same. Make sure that you understand the following: correlation, line of best fit, interpolation, extrapolation, and outlier. In I'm Building My Confidence, you will have some scatter graphs to analyse just like we have done here. In I'm Ready for Anything, there are 2 scatter graphs that need to be used together. By doing this, you can find the relationship between 3 variables. And then in the extension, you are looking at some common misconceptions, some errors. Can you spot what is wrong with the scatter graph? And also you'll be looking at the different strengths of correlation. Pause the video to copy the notes, to check your understanding, and to try the questions from I'm Building My Confidence and I'm Ready for Anything. Remember to mark your work and reflect on your confidence.